All right, this is part 2 of trying to 3D model a bracket I can 3D print that will help me mount this sort of bicycle hanging bracket to my wall. If you saw the first one, I want to mount a 2x6 to my wall because I have a bunch of 2x6s sitting around and I can mount them to studs. And that gives me a lot of freedom about where I can actually put these bike hangers, so the front wheel or rear wheel. This hook just hangs onto one of the wheels, and then it hangs, and then this can pivot, so you can sort of page through your bikes. Anyway, get them up off the floor, get them out of the way. And so one of the main challenges is the holes for this bracket are too far apart for the width of a 2x6. So the solution I've come up with is to 3D print some hardware that will allow me to, with a slight modification to the 2x6, hang this on, slide it back and forth, and set the spacing. So that way I don't have to pre-decide on the spacing between the bikes as well. I'll be able to move them around. And so initially, if we're looking at this from the side, and so we've got our 2x6 here like this, and then we have the side profile of this bracket. You know, the holes are like here and here. So what I was planning on doing was just routing out a little chunk of the 2x6 on the top, routing out a little chunk out of the 2x6 on the bottom. And then actually, you know what? We'll just use the eraser tool here. And we might want a larger brush for that. And we want a square brush for that. Planning on routing out a little bit of the 2x6 top and bottom. And then I would 3D print. Let's grab a different color here. 3D print something that would basically fill in this space here. Have a captured nut inside here so that the you could bolt this to the bracket, hang this on here, and then I would 3D print basically the same thing. In fact, my plan was to use the exact same part, just upside down. And so that the bracket could hold onto this 2x6, but I could loosen up these bolts, slide it around, that sort of thing. I've actually changed my mind on that. So I actually only plan now to route out the top portion, same as before. 3D print a hook, very similar. Whoops, that's not the button I wanted. That's the button I wanted. 3D print something that will fit in here like this. And then I want to 3D print something down here that will just prevent this from coming off. So probably something like a captured nut. This might be kind of hard to, I don't know, draw in GIMP with my mouse, but something kind of like this, not like that shape, something like this shape, like a foot, and then a second piece that's got the captured nut over here, so that when I loosen this foot, I can slide it back and forth to loosen it up so I can move the bracket around, and then I can slide this up tight against the board, tighten it down, and that'll just prevent it from coming off. That way I have a way of sort of moving things around and then tightening it back up. And all this does, so this hangs like a hook, and then this just prevents this from being able to come off when I don't want it to, when I'm, trying to hang a bike on there and I'm bumping my tire into this and it's, lifting up on that. Just prevent it from coming off. The other goal this accomplishes is that there's a variance in the dimensions of this 2x6, within a couple of millimeters. So, if I'm trying to make something sort of tightly dimensioned to fit this routed pocket and that sort of thing, it doesn't really give me any give or variant. It doesn't give me any allowance for variance in the 2x6, but this will. So I'll just give myself, this distance, whatever this ends up being, and I'll just arbitrarily decide on how deep this route is. That amount of move plus, 5 or 10 millimeters, something like that. That way I'll be able to hang it on, slide this foot up, and account for any difference in the width of the 2x4. So once again, as before, we're going to do all of our modeling in FreeCAD here. And I actually found a FreeCAD that I did not know existed. I don't know when this was added, but it allows you just to create this sort of parameter objects. Then you can reference them in the dimensions in sketches and pads and things like that. So we're going to try those out. So I just added a couple dimensions here. So I added the depth and height, probably more appropriately width of the width and thickness. But the way I'm thinking about this 2x6 is the height, because it's going to be hanging vertically, and then the depth. Just due to the orientation of the 2x6, I chose those. And then I just added one value for the hanger itself, and that is the distance, the center to center distance between the two holes. That will be important for us. And maybe we'll add others. And then I sort of scope them by creating two of these objects. And I think you use these names in the actual references. So we'll find out. So we've got one body here. I'm actually going to rename this to the 2x6. I don't really need to model this, but I think it'll just be handy to have, when we're doing drawings and just trying to visualize the whole thing. So we'll model that as well. And that's a super easy one. So we'll start with that. And we could probably just do it with this solid, create a primitive, but I'm more comfortable starting with a sketch. So I'll just draw a rectangle. I'll use GR to do that. And then we'll create a height dimension for that. And I'm going to hit equals. And then I think what we do is we call it board. Yeah, so I think this is our object. And then height. Yep, right there. We'll grab that. Cool, 139 millimeters. Great. We'll create a horizontal length here. And so we'll get into expression editor by hitting equals, and we'll go board dot depth is what I believe I called that. Got that there. And then I'll just create a constraint to, the only thing that the position is the only thing that we have open. I think I'm just going to use the symmetric constraint, which is S, I believe, to just center this thing on the origin. I don't know. Maybe I'll regret this and wish I had put one of the corners in there, but for now, we'll just center it on the dimension there. Close. And I could have done this in one sketch, but I'm actually going to end up doing this in two sketches. So we'll pad that out. And this is pretty arbitrary. We'll just pad this out to, I don't know, 1 meter, something like that. Okay. Actually, you know what? I really don't want that to be 1 meter. We're just going to make this, so I don't know, like 100 millimeters, just to make it a little bit more manageable. Okay, cool. And then we'll also, we'll come up with some dimensions for this top route here, or for this like routed place where I'll be able to create like a hook-like feature on my 3D print to hang it. So we'll just select this face. We'll create a new sketch like that. Do GX to bring in external geometry, GR to draw a rectangle from that corner. We'll go like that. And you know what? If we just snap this with a coincident constraint to there, I think my plan is to do roughly half of the thickness. I'm going to leave myself some space, as you'll see in a little bit there. And then we just need to decide how much hook we want. I don't think we need a ton. I'm just going to choose a variable or a quantity at random. We'll do 15 millimeters if I could type like that. So we'll get out of here. Where's my leave sketch button? There it is. And then we'll just use the pocket tool to go through, and then I'll just do through all. Okay, so this is what our 2x6 is ultimately going to look like. And like I said, I'm not going to be too critical with the routing, and like there's some variance in the dimensions here. So we'll leave ourselves some space when we actually go to draw in our hook feature. And that's what I'm going to do next. So I'll create a new body. For that, we'll call it hook. Okay, rename it. Renaming things tends to be helpful. And so the first thing I'm actually going to do is I've got this feature, or I've got this body selected, but I want to create a shape binder from that. So we'll just click the shape binder, and that'll give us some geometry that's inside this body that we can reference. And in fact, now we can just hide our 2x6. We no longer really need it. We'll create a new sketch in here. And we'll, actually, cancel. I want to create the sketch on this shape binder's sort of plane that it's creating. So we'll create a sketch there. I don't know. For some reason, I don't like selecting the geometry after I click the create sketch button. I like to select the geometry before. Then you can achieve the same thing, and it's not all that important. But anyway, so I'm going to leave myself some space in both of these sort of axes here. So, and then we're just sort of arbitrarily assign some space up here. Basically, just enough room for the nut to be embedded inside that print. So I'm just going to do that with a multi-line, and we'll put that on here. And just one second. Just dealing with a separate issue here. Just need to send a message real quick. All right. And then we'll continue drawing our multi-line. We'll add some constraints to that. We have a few, in fact, all of them that I wanted to add. Horizontal and vertical constraints have been added. Great. We'll create some external geometry that we want to reference. I'm going to constrain that to here. And I've already made... I have to make a decision. Do I want to leave myself some variance here, or do I want to tightly constrain that? And I actually think I want to leave myself... you know what? I am going to constrain it. I am going to constrain it. So if there was actually some clamping force between the 3D print, the bracket that'll be on this face, and this, I think that would be actually not desirable. So I'm going to leave myself some variance there. So I'm going to get rid of that coincident constraints that I've got down here. That's on the y-axis there. We're going to reconstrain that to be vertical. And then I'm just going to set a distance there. And it's not going to be much, maybe 0.5 millimeter. So we'll set some distance constraints here. We'll go probably like 0.5. We'll go 0.5 here. And like I said, when I'm actually doing my routing, I can do some tuning of this. But that gives me 1 millimeter of space between the sort of the wall and the 2x6 there. So that should be fine. And I'm going to give myself maybe a whole millimeter here. Then I need to decide how tall I want this. So the nut that I'm going to embed, the corner to corner distance on that is about 12.5 millimeters. I'm not sure which orientation I'm going to put the nut in yet, but we'll just do like 5 plus, maybe we want to have at least 5 millimeters on either side of that. So we'll add 10 to that, which was pretty close to how the sketch worked out anyway. Cool. So I'm going to get out of that sketch because it's now fully constrained. That's why all the lines are green. And then we have to decide on the sort of the depth or width of this bracket. And actually, I think what I'm going to do So I'm going to go back into this sketch and create a reference because capturing the nut is really what I'm concerned about here. And I think that's basically my same concern on the depth of this part as well. So I'm going to make this thing a reference and we'll give it a name, or is that what I want? Reference or constraint dimension. I'm actually not sure what that checkbox does. Maybe I don't need to do that. If I give this thing a name, I'll be able to reference it in the other sketch. So we'll give it a, I don't know, beefiness. Is that a word? Anyway, we'll call it beefiness. And then if I close that, I think I'll be able to reference that in the pad. So let's check that. I might need to check that reference box. I'm actually not sure. And we'll go reverse for no real reason other than it will line up better with my other my 2x6 body. Although it doesn't really matter. And the dimension, we'll just get in here. We'll go equals, and we'll go sketch.beefiness. I got the name of the sketch, and then hold on. What is the name of that sketch? Name of that sketch is sketch 002. And I might need to make that a reference dimension. Let's just see if that changes anything. Close. Oh, okay. Okay. I know what this checkbox does. Actually, cancel. This reference checkbox, what it does is it's no longer a driving constraint. It's no longer saying make this dimension, make this distance or whatever, this dimension. It's saying other constraints are applying or are setting the height or whatever of this, and then we just want to apply a label to it. So we want this to be driving, so we don't want to check that. But why can't we reference that? So it's sketch 002. Oh, label dot beefiness. Oh boy. It's in here somewhere. Dot constraints dot beefiness. There it is. Okay. Sketch 002 constraints beefiness. Okay. That's my 22.5. Could have put that in a configuration object. Maybe that would have made more sense. Anyway, so I think that's good. Now we need a through hole in this, and we're just going to put it right in the center of that. So we'll create a sketch. And if we do a line on the top and the bottom, that'll get me if we add external geometry from the body into there, that'll give me a good way to center this hole. So basically, I've just got a bunch of these 1/4-inch bolts lying around, and they're a pretty good length for what I want to do. So I'll measure like the external thread diameter, and it's unsurprisingly about 1/4 of an inch. So we'll set the diameter of this to be 1/4 inch is 6.35 millimeters. I'm going to be printing this on its side, so I'm going to give myself a little bit extra here. We'll give maybe 6.75 because this is just a through hole. And then we'll use the symmetric constraint to put the center of that hole in between the center of those diagonal corners. So that should be right in the middle of that face, of that square. So we'll get out of there. We'll pop a hole in there. We'll go through all. Okay, so now we've got a through hole that's through all of that. That's good. So now I need to decide. Sorry, I want to recess a nut into this. So I'm going to put a sketch on this face. And I want to print this flat on its side. So I have to decide how I want to orient that. Anyway, sorry. We're going to drop a sketch on this face. And we're going to drop a hex onto this. We'll bring in the circle or the hole as external geometry. And we'll use the polygon tool, which defaults to 6 sides, to drop a polygon on here. I'm going to use the horizontal constraint to make that horizontal. So since I'm essentially going to be printing it on flat on this side, I don't want a flat overhang here. Actually, or do I? Because those will be bridges. I think the bridges will actually probably print better than these super steep overhangs. I think I said the opposite in the last video. And I did print some of those, and they worked okay, but these are pretty steep overhangs, and this is a pretty small bridge. So I think I'm actually going to switch what I just said. So we'll delete that horizontal constraint, and we'll make this a vertical vertical constraint. Bang. And I applied 2 conflicting constraints there. We'll get rid of that. Vertical constraint, V key. There we go. So now we're going to be printing a small bridge instead of super steep overhangs, which I think will actually probably work better. Then we just need to set the dimensions of this. So the flat to flat dimension on this nut should be 7/16 on a quarter inch, or no, half inch. I think it's half inch. Anyway, but we're drawing in metric, so I'll just literally measure it with my calipers here. That's 11 millimeters. We'll give ourselves like, I don't know, maybe a quarter of a millimeter to play with. So we'll just do horizontal distance, and we'll just do that between these 2 points. We'll give ourselves 0.5 millimeter to play with there. So that's fully constrained now. So we'll get out of there. And so this next part like broke my brain in the last stream. I eventually did figure it out, but I was totally second guessing myself. So basically what I want to do now is to figure out, I want to capture the maximum amount of plastic in here and make sure that I've got like full engagement with this nut. So I've got this nylock nut. I want this to be all the way through. So what I actually want to do is measure the thread depth of my bolt. It doesn't have to be super precise, but I want to get a pretty good idea of the thread depth, which is about 37.5 millimeters. And then I want to subtract everything that the bolt will be going through to come up with the distance between this face and how deeply I want to recess that nut. So I'm going to draw a reference face based on this one, and I'm going to offset it in the Z direction negatively. Basically, everything that this bolt has to go through to capture the nut. So that includes the nut. So the height, or sorry, actually, let's just get into the formula editor so I don't have to try to remember these things. So I'm going to start with the full depth of this, which I think I said was 37.5. See, I'm already forgetting. Yeah, 37.5. So 37.5. And then I'm going to subtract the height of the nut because I want it to go through that. So that is about 8 millimeters. I'm going to subtract the thickness of this bracket because it's going to go through this bracket. Thickness of that is about 3 millimeters. And I'm also probably going to put a washer in there, and I don't have the washer down here, but let's just give ourselves like, I don't know, 2 millimeters of washer that I also want it to go through. That way the hex head is bearing, when I'm tightening this down, going through this hole, the hex head is scraping on and bearing on a steel washer. I don't know what the hardness of this is. I trust a washer a little bit more. So we're going to subtract all of those. Okay, and that actually went the wrong way. So I think if I just click the flip sides button, that does what I want. So that will put this plane essentially. Where did my bolt go? Going through everything, it puts that plane right at the end of the nut where I want it. So that's how deeply I'll need to do this pocket, cut this pocket into the body. So that's all good. So I'll go back to my model. I'll grab this sketch, and then I'll do my pocket tool. And instead of dimension, I'm going to say up to face. And I believe FreeCAD will let me select a datum plane or a reference plane as a face. And it indeed does. Cool. Okay, so I think this part, I'm going to hide that datum plane. Hide the datum plane. So I think this part is essentially done, except I do want to drop a couple of chamfers on here just for fun. So I'm going to select this face. I'm going to hit the chamfer tool. And then I'm going to hit select so I can add some more things. You could hold control and select everything you want as well. I don't know. I just find it a little bit easier to select, one thing and then add more chamfers as need be. So actually, the only thing I really don't want to chamfer is this inside corner because I'll probably have a pretty sharp. Actually, let me bring the 2x6 back in. So that inside corner will be referencing this edge of my 2x6. Come on, right here, and that'll be pretty sharp because I'll be creating that with the router. Like the outside corners of this 2x6 are pretty rounded, just because that's how they come from the factory, sawmill, home improvement center, whatever you want to say. But this one will actually be pretty sharp, so I don't want to throw any kind of chamfer or radius there. So I'm going to go back into my chamfer, hide my 2x6 again, and we'll add some more edges to that one. We'll add this edge, this edge, this edge. What's going on here? Edit, select. There we go. This edge, this edge, this edge, and I could switch to wireframe. That might be a little bit easier. We'll grab this edge and this edge, and we'll click OK. Okay, cool. Now that is chamfered the way I want, and I think that's going to be good. So we got our top hook, and I'm actually not quite sure what I've done here. I thought there should be 5 millimeters between this and this, but I don't have that, and I'm not sure what I did wrong. Let's go back to back to this initial sketch. So I want my hole to be in the center of this. I measured, I think, 12.5 millimeters. Yeah, corner to corner on that nut. And I added 10 to it. So shouldn't that be 5 above and 5 below? But that clearly is not the case. So if I drop a sketch on this face, we can do some measuring here. I'll bring in this as external geometry. I'll bring in that, and then I'll rotate this around. Oh, you know what? I think it actually did work the way I wanted. I I don't know, just didn't look like it for some reason. My concern was that I didn't have 5 millimeters top and 5 millimeters bottom, and I just wasn't sure where I messed up. So if I just drop in a dimension here, oh, I don't have a line. I'm actually going to delete that. We'll drop in just this line here. Okay, now I can do some measuring. And I think they actually improved the measurement tool a little bit just in the part design workbench. So we probably could have done that, but I just want to get a vertical dimension here. And that's a reference. I think that's why it's blue. And I should have drawn in both of these. Four 4.6. And that is just because I made the hex. It's not exactly 5 because I made the hex a little bit larger than it actually needed to be. So I could actually get the nut in there. I'd have some clearance. So, okay, cool. So we're in a good spot there. Sometimes it's nice to just do that little sanity check, make sure it's working the way you want. Yeah, for some reason in 3D view, this just did not look like 5 millimeters between this point and this this face over here. But anyway, it in fact is. So we'll bring our 2x6 in and just rotate this around a little bit. Now, I think I don't probably strictly need to do this, but I think I'm going to draw in the bracket, just draw a little representation of the bracket, just so I can see where the other hole lines up over here. You know, you could do some calculations or whatever, but I think having external, like just having a body and then being able to reference the geometry from the other body will just make it easier to think about. So we're going to grab a new body, and we'll call this the, I don't know, the actual hanger. We'll give it a name. And then I'm going to grab probably this as a shape binder or an external shape binder. So we'll go ahead and do that. And then I'm going to select that and draw in or add a sketch. Wait, cancel. What have I done here? Oh, I think when I click this, I selected the face from that chamfer. If I select it here in the model tree here, then it should do what I want. God, for whatever reason, I hate selecting the. So we just need to hide this. Then I can select this, drop in my sketch. In CAD, there's often like 1,000 ways to skin the same cat. And this thing is like rounded and, you know, has a goofy shape. I don't think I really care about that. I think I'm just going to draw a rectangle and a circle and draw the holes. So we're going to go grab that. I'm going to draw a circle down here somewhere. Draw a rectangle up there. I'm going to drop in some external geometry. I don't know if FreeCAD can do this yet. In the Real Thunder branch, you can actually just toggle external geometry into driving. I don't think you can do that here yet. Hopefully they merge that soon. That might actually even be in 1.1. I've got 1.0 here. But anyway, we can just use the equality constraint to make those equal. And I got a coincident constraint just by how I drew the circle. I actually also want this circle to be equal to this circle. I want them to be vertical. So that should be constrained in everything but distance. And then I can use I to set the hole diameter. We can get into the expression editor with equals. And then what did I call this? You know what? I can just go over here and reference it. Can't I? Can I not switch to that with this open? I guess not. I can't remember what it's called. It is called hanger. Of course, called the sketch hanger. Then I can't remember. Equals hanger. And then whole distance. Perfect. And then for whatever reason, we didn't get our equality constraint on the diameter of that. There we go. And then this rectangle is like super unimportant. I'll probably just like coincident constraint the corners of this. I'll drop in a reference here. Give it a name. Yeah, right now we're over constrained because the distance is being set by my coincident constraints and the distance or the length I'm creating here. I don't know. I'll just give it that. And then we can come down. Come on, scroll wheel. Come down here, do that. Set a distance here and just make them the same. Or actually, instead of doing that, I'm not going to do that. I like to do this with geometry, probably better than anything. So I'll just go to line and we'll make it reference geometry. So we'll draw a line just from these 2 points. And then we'll come down here. We'll draw a reference line between these 2 points. And then if I make those equal, that will solve all of my problems. What have I done here? Oh, left my sketch. I'm hitting keyboard shortcuts I don't even know. I need to get one of those screen keys applications running. Anyway, okay, cool. So that's fully constrained, which probably wasn't even that important, but it's nice to have things fully constrained. And I think I called that 3 millimeters. The thickness isn't really that important, but we'll go, we'll pad that out to 3 millimeters. Okay, cool. So now we'll be able to come in and draw our, like, I don't know, little foot down here and our captive nut. And I think I'll start with the foot. In fact, you know what? I don't even know if I need to model a captive nut. I wonder if I can just put one of these nuts into, focus, come on, into a slot, if that will be enough to hold it. We can try that. And if we need to 3D print something, then we can do that. But start with the simplest thing first. So anyway, we need a new body. So we'll drop in a new body. I'm going to call this the foot for some reason. I don't know. And I want this to be able to move this distance, which I think was 15 millimeters. And I'm actually going to give that a name. I'm going to give that a name. So we got to go back up into here, grab this sketch from this pad. Not that one. In the hook, this sketch. I'm going to call this the clearance distance right here. I will make that a reference, and we'll call it. Okay. Close. And it's probably going to take me like 20 minutes to figure out how to reference that, but that's fine. And then do we need to do a shape binder of any kind? Yeah. So we're going to want a couple of shape binders, I think. So we're going to want to activate this body, which we are. I'm going to click on this face. I'm going to want that. And we'll do a shape binder for that. And I'm probably going to want this too, so I can locate that hole. I might regret that, but we're going to grab that too. So we got a couple of shape binders. I'm going to hide. You know what? We're going to want one more. We're going to want the side of this board. Grab a shape binder for that. And then I think I want to hide everything else. There's probably a smoother way to do that. So we've just got our shape binders visible. I'm going to grab that. We're going to draw a sketch. Get some external geometry in here to reference. That's going to come in as a line, which is perfect. And then the look at sketch button is really handy when you've moved things around. So now I basically need a foot. We're just going to start by dropping in a multi-line. And a lot of times I like to, okay, hold on. I'm going to try that again. I actually like to sort of avoid having it drop in auto constraints. Like, I could have drawn that on this line, but I found that occasionally FreeCAD will do a thing where it's trying to auto constrain it horizontal and do the coincident constraints on this line, and then it gets all mad at you. So sometimes it's easier just to draw the shape wonky and then add the constraints that you want. And I know you can turn off auto constraints too, but sometimes they're handy, sometimes they're annoying. I don't know what the right answer is, but we'll just roughly draw in sort of the shape I'm thinking here. And then we'll add some constraints and some dimensions to this. And I heard somebody else say in probably a FreeCAD tutorial that they like to do constraints and then dimensions, I guess, which are also constraints, but they like to do the non-dimensional constraints first and then drop in the other ones. I don't know. What are your thoughts on that? So we're just going to drop this one right in that corner. We're going to drop this in. We'll give ourselves, maybe 2 millimeters there. This is going to be pretty arbitrary. Make this, 15 millimeters. And then actually, just given the distance I'm looking at here, I don't think we're going to have to be too concerned about that clearance reference made. I'll just make this, 135 degrees. Something like that. I'll make this coincident with this. Something like that. And then how thick do we want this to be? So I actually probably want this to be pretty thick. I want it to be the height of the nut, which I believe was 8 millimeters, plus a fair bit of material. I mean, this really isn't going to take any load. This is literally just to keep the bracket from falling off when I'm trying to finagle a bike on there. So I don't know. Let's set 15. Maybe we go like 20? What does that look like, just aesthetically? So that gives us 13 millimeters of stuff to clamp into if I get full engagement on the whatever. I don't know. I might regret that. We're going to leave that for now. We can always come back in here and change this. So we're fully constrained. We'll grab that. We'll extrude that to that beefiness value. Let's see if we can figure out how to reference that. So equals, so that was from the hanger or the hook, sketch 002, I think it was. Probably should have named the sketch and then its constraints. I mean, I know it's 22.5 millimeters. So I don't know. This maybe makes more sense to put it into one of those parameters. Like I said, it's just going to be. So I'm pretty sure it's sketch 2. And then Why don't you prompt me for something? I actually don't know the difference between referencing these things with the angle brackets and referencing them without either. So I'm pretty sure that dimension was in the hook body. You know what? Let's just go look before we get too crazy here. Yeah, hook, sketch 2. And we gave this a name of beefiness, right? Okay. So how do we reference that in this pad? So, hook. That's really interesting that the other body names are in here. Let's look at what it was in that pad. Let's go into this pad in the hook component here. This is where it's referenced. Actually, can we do it without going into this pad? Yeah, sketch 002. Constraints beefiness. Okay, let's go into our new pad. Not found in hook. Well, that's definitely not it. So let's try. That's not it either. How do I get the reference from that other body? Maybe we do. Properties sketch. What properties are in here? Like, tell me. The double angle bracket seems to like take you up to like a global scope. Oh, okay. Interesting. So that does it. To me, it would be like you're accessing these things like through the hierarchy, but it seems like the double angle brackets take you up to a global scope. We'll reverse that just so everything's in line. And I don't know how to use assemblies in FreeCAD. Okay, so that's good. Now we need to drop in a slot for our nut. So we're going to do that from, from here. We'll drop a sketch in on this face. And I think we're going to have plenty of adjustment, but, we can use our dimensions anyway. We'll drop a sketch on here. I want to drop in some external geometry, which we'll need to bring one of our shape binders. We'll just bring them all back in. No, we don't want that. So we need this hole. And we'll need, actually, I think that's it. So we're going to draw I'm going to use multi-line again. And I got to look at this sketch. This is just at this angle. Messing me up. Anyway, so we need to draw basically like a super long hexagon. How long that is will depend on some dimensions. We got verticals there. Okay. Then, actually, you know what? I think I'm going to do this a little bit differently. This might be a silly way to do it, but we're going to draw actually just 2 hexagons. Like a slot hexagon? Nah, this is dumb. We're going to bring that back in. You know what? No, I am going to go back to my slot hexagon maneuver here, just so I can set the center points easier, and then it'll also do the angles for me, because dividing by 6 is hard or something like that. Anyway, so we're going to draw in 2 hexagons. We're going to draw them in as reference geometry. So I don't actually want to center. Whoops, I actually just did that. I actually don't want to center this hexagon on that center point, because I want to be able to take up some slack if the like the way this is drawn is that the foot would be like, how do I word this? If I center this hexagon exactly on the center of this hole, that would mean I have no like extra space to move this foot up into the 2x6 in case I'm at an area of the 2x6 that's a little bit longer. I always want to be able to like clamp that firmly so it's not rattling around. Okay, so let's look at the sketch again. We're going to make, what kind of constraints we got here? We're going to make this vertical. We're going to make one of these vertical, in case it wasn't already. We're going to set this equal to one of these. I guess it doesn't really matter which one. I want this to be vertical to this. Whoops, into this. To this. I want those to be vertical, and then I want this to be vertically constrained to this. I'll probably set some limit here. I don't know how much extra clamping I need. Probably like 3 millimeters, just some arbitrary dimension. That's fine. You know what? This is dumb. I've thought about this all wrong. We're going to get out of this sketch. We don't need to do all this complicated hexagon nonsense. We can delete this sketch. Instead, we can draw a sketch on this face, and we can do a rectangle. like this. We want this about 8 millimeters deep for the full height of the nut. We got stupid. Okay. And then just to center it, we'll just use just a geometry trick like that. So if we make that equal to that, then this will always be centered on there. I'm sure there's other ways to do it. That's the, I don't know, most intuitive way I've found. We want this to be 8 millimeters tall. And then we want this to be a pretty snug fit on the flat to flat distance, which, what did we decide that was? 11. 11. So I'm going to actually go like 11 and a quarter, because since I'm not constraining the full hexagon and I'm hoping to get away with that, I want that to be pretty tight in there. We'll go 11.25. Okay, now we can make a slot just by pocketing that into there. And then it doesn't really... Oh my God. Okay. Should probably make the slot on the right part of the... You know what? I'm just going to start over. I probably want to put the slot in the right place. So let's try that again. We'll generate a rectangle, a GR. We'll grab it in there. I'm going to select all these, GN, GL, to drop in some lines. Could put them here too, but then you've got collinear lines. It's kind of hard to see. So we'll grab our equals tool with E. We'll make those equal. We'll make this our 8 millimeters of depth. And we'll make this our 11 and a quarter flat to flat distance. Probably could have made that a parameter. Anyway, close. Now we can put our slot in there. We can actually just draw through the whole thing. And then we have like lots of availability. And we can actually slide it in from the bottom. But then it might fall off if you loosen it. So I'll probably just actually just drop that slot up until there. That'll be way longer than we need it. And I can't think of any reason not to do that. So we'll use does up to face work with a line? Let's see if that works. Can I grab this face? I can grab that face. Oh, interesting. It extends the face down. Do I want to do that? I don't think I want to do that. Let's not do up to face. Let's go up to first. That'll grab it all the way through there. That's really not what I want. Up to shape. And then can I select this one? Select shape. This one. Did that do what I wanted? Nope. Cancel. So one thing I could do is drop a reference face on this. It's not going to do what I want, and I never have any idea of how these work. Cancel. What is the way that I want to do this? Let's try this. What if we... no, never mind. You know what? This pocket up to face, this face, I think will be fine. What am I doing here? Up to face. We'll select that face. That's not what I want. Anyway, I think that is going to be fine. So we'll grab that, or we'll do that. Cancel. Okay. I have a sneaking suspicion that it's not really going to be what we want anyway. And then the last thing we need is an actual slot for the bolt to go through. So we'll cut that slot by drawing a slot on this bottom face here. Actually, the last thing might be some chamfers. We'll drop in some external geometry. And then we'll grab a slot. And we'll draw that from, same as before, just below to somewhere there. That'll make it vertical. We'll grab it like that. Okay. So if we make a vertical constraint between the center of this arc, which I can't actually see. Why can't I see that? Why can't I see the center of this arc? Oh, I can. Never mind. Vertical constraint between the center of that arc and the center of that circle. And then if I just make this circle tangent to this guy, that should take care of that. We'll just draw in our arbitrary 3 millimeters that we decided on from before. And then, turn off look at so I can actually see what I'm doing over here. We'll just drop in some external geometry from the other side of that. And then this is always kind of a challenge. We'll just drop in a line. We'll make it horizontal. Hold on, look at my sketch. It already was horizontal. We'll make it reference. Then we'll make it tangent to this. We'll make it like equal to that just for fun. We'll make this vertical. This is all unnecessary that this is constrained. But anyway, now I can do this and just drop a vertical constraint on there. I guess this would be half the point-to-point distance. So the point-to-point distance is... Oh, no. Actually, it would be smarter to constrain that from the center. So we didn't need to do any of this. So from basically from the center of this circle... basically, this slot is going to decide how far the nut can slide in the slot on the other side. So basically, it doesn't make any sense to make it go any further than the point being able to touch where this sort of ramp feature is. So from the center of the circle to that ramp feature is half the corner-to-corner distance on the nut. So we'll drop that in right there. I thought I hit I. I did. Okay. So that was, 12.5 millimeters. Yeah. So we'll just say, we'll call that 14, give a little clearance. Half of that is 7. So we'll go like that. Okay, cool. That slot is now fully constrained. We can punch that through there with a pocket we want through all this time. Cool. So now we've got a feature that we can use to sort of clamp. What am I doing here? Model will turn on all of our bodies. Which, is there like a show all? I don't know. I'm sure there is. And we'll turn on our hook. Where's my hook? Why isn't my hook on? Because that's not on. Okay. And we'll turn off our shape binders. Those are a little bit annoying. Okay, so now I think we're in pretty good shape with what we want. And we turned off this guy. Okay, so we've got our mounting plate. We've got our hook that'll hook onto the top. We've got our foot that will take up the space in the bottom so that this can't come off of here. We've got a place for the sort of embedded nuts to go. This one's going to be in a slot, which will hopefully at least allow me to tighten this up. Like I said, this doesn't need to be super tight. Just needs to hold this so it doesn't slide off. And that will hang on the 2x4, or sorry, 2x6. Oh, you know what? Let's drop some chamfers off on this because reasons. They're just nicer to handle. So can we solo this? Toggle. I don't know. I think it's space to toggle visibility, right? I'll just click the eyes. Turn off all those. We'll drop some chamfers in on this. Probably on pretty much everything. Let's just grab like, oh my God, come on, selection. I've got my cursor size turned way up and it sometimes makes it hard to figure out what you're actually selecting. And we don't have this body active. Double click, cancel, double click to make that active. Select this face, hit chamfer. And then we will hit select and we'll grab more edges. So I think I want all these. I don't really want the slot, so we'll select all those. We'll get all those. I don't want these interior ones. I want, but we do want like this one and this one. Does that get everything that we want? No need to chamfer this really because that's already a 45. Everything else is pretty nicely chamfered. I don't really want the slot chamfered. I think that's good. So I'm going to stop it there. I'll print these out and route out one of my 2x6s. And who knows? Maybe we'll do a part 3 on this one.